When something happens with the application and people come to developer and saying, hey, please fix the app because it is slow or not working at all, developer cannot fix without understanding what exactly is causing the issue. Is it the database that maybe some index is missing? Is it networking to some third-party API? Maybe something else, maybe disk is lagging behind. Maybe there is some kind of loop and calling way too many calls to the database, even if the database is quick to respond, but just the amount of calls is just too many. Like the developer doesn't know exactly what is happening without the investigation. And Traces allows to investigate very effectively. So for example, in this particular case, I have a sample application which is running, and I created a little bit of load just recently. So let's zoom to the last 5 minutes and see what happened. So we can see that there were just a little bit of traces before, and now suddenly we have a spike. Like it's not a huge spike, but it could be any kind of spike in production environment. And we can zoom in and see what is happening during that moment in time. Let's zoom in even more. And now we can see that during those seconds, we had a little bit more of spikes. Now let's see what kind of traces do we get. And we see that this was post-operation to the API. And let's take a look, for example, at this one. We can see, oh, maybe this one. This one took 59 milliseconds. It's more than others. Let's see why it is happening. Let's go to inside the trace, and inside the trace we can see that this call happened to begin with the post request to this API endpoint, and we can see everything related to that request. We can see the attributes defining how we instrumented the code, what kind of server is running, what is inside of that server, everything related to that request. And then we can click on another span, which is inside the same trace, because the trace can have multiple spans, and each span is basically a new operation of something. You can define easily with OpenTelemetry your custom spans. For example, if you have a function which you want to track how quick that function is, or just you want to create a span with custom attributes for that specific function, you can just open span and close it anywhere in your code as you need to instrument your code. But many libraries like Mongoose in this sample for MongoDB inside the Node.js environment has automatically added OpenTelemetry to the library, and many libraries automatically added already OpenTelemetry support. So really, this one happens automatically. But you can click on this span and see what kind of action happened. So we can see that it is related to Mongoose profile count document. So we already have some kind of clue what is taking most of the time. Like the trace took almost 60 milliseconds, and out of those 60, 53 took for Mongoose. So we know where to look now. Once we scroll down, we can see that database statement was to count documents, and condition was by workspace ID, and there were no more options. And the collection was profile, and the database was _prod. Like we can see everything related to this call, and now we can reproduce this statement and see maybe the indexing is wrong, maybe something else. Of course, this timing is good, but it could be a second, it could be just an error altogether. Maybe the database is down, or it is timing out for whatever the reason. So inside the trace, developer can tell exactly what is happening and how long it took, and can create custom traces, custom spans. You can see exactly what is happening in your software. Let's look at another span. In this place, we have the cron job, and we can see that it is taking just 12 milliseconds. So this trace was started not with the post request, it was started by the cron job. And it did nothing much in this case. So it was just one span. Now let's take a look at a little bit more of the time. So we were looking at the last 5 minutes. Let's take a look at the last 24 hours. And then we will also use the extended search options, which include all kinds of things, including the span scout. So let's find some trace which would have more things happening. So for example, let's see at the traces with at least 5 spans. And we can see, for example, this one, post private event list. In this search area, we can search by trace ID, span ID, service name, app name, host name, or operation. So in this case, let's look for post/private, why that is the operation for all API endpoints used by the software. And we can see that, for example, this one has event list and it has 7 spans. This one has 8 spans. This may be too many, and for our case, it could be normal that a single trace has even 50 spans. But for example, I want to know exactly why does this operation need so many spans in this case. I'm not sure, so let's go into the trace and see what is happening. And we can see immediately that we have some kind of loop which is going to the MongoDB. If we look at it, it took 15 milliseconds for this API endpoint to resolve. And everything basically what happened inside is just going to the Mongo. Event name find one, profile find one, event name find one, event name, profile find one, event name find one. Seems like a loop. So sometimes in the code you may have something like this looping, and at first maybe it is nothing special. Maybe you are good. You just have a couple of data points anyways in your database, and it is working fine. But time goes and you scale up, you introduce a little bit more customers, you introduce a little bit more data in your database, and suddenly such loops start to lag behind. And without traces, it's very hard to identify such points. With traces, it's straightforward. You just find your slow traces and you see exactly what is happening inside, and then you go to your code and check what happened. So for example, for this case, we can also click on this trace, span number 2 for mongoose event find one, and inside the attributes we can see exactly what happened. We can see the condition, the statement, collection, database, like everything what is happening. In this case, we are also adding even the result response. What you want to add as a statement and the response is custom. By default, this Mongoose instrumentation does not include the statement and the result, but I added it easily as a configuration option for OpenTelemetry, and now it has these data points as well. So with traces, it's super easy to investigate. Another thing which we may care about is logs. So we have this trace, and let's say we had an error within that trace. We want to see if application emitted any kind of logs during this trace. So what we can do is we can click on trace logs, and then it will navigate to the trace log to the logs section, and it will automatically add the trace ID to the search field. And I set up my OpenTelemetry in a way so every log message has the trace ID as well. But even if I would expand that, you can see that OpenTelemetry adds a little bit more to the logs as well to make you more efficient when figuring out who is emitting that log and what is happening exactly. For this log message, the log message was just request post and this thing. But if I would go to log attributes, I can see exactly what is happening. Who is the caller, what kind of application, what service name, especially if you run microservices or some kind of background cron jobs, you can define the name of those cron jobs and know exactly who is emitting that log. I can see my runtime and all kind of other information. We can see, depending by the setup, it could have more attributes. In this case, it just has the log attributes. If you are looking at the log message, let's clear this up. Now I'm looking at many log messages, and let's say I want to look what's inside this one. Again, you can see that this log message was formatted in a way so it would be just a text, and it would be possible to search by it. For example, if I would want to search by this one, I would be able to do that easily. Even if my log is JSON, I can search by it like so. Like you get the key value, the key name, the value name. You can search by any part of that message because all messages are stringified into a single string, so it would be easy to search. If I would expand that, you will find that this actual raw unformatted log message came in like this. So, for example, if your system would allow to search, but it would not format the code into the searchable way, if you were looking for something which extends between two lines, you would just not be able to find it. With Otelic, that's not an issue because all the logs are stringified into a single line, and then it becomes searchable. And the last part is alerts. Inside the alerts, what you can do is, first of all, you can create destination, and for the destination, you define your webhook. And for the alert part, you can define when to trigger that webhook. So, for example, you can say I want to track logs and I want to see by the errors, and let's in this case you can preview it during last 15 minutes, and this one you can preview last 7 days to get a better feeling what you are filtering out. And in this case, for example, I'm looking at error logs. If those error logs make sense to me and I want to be triggered when I have way too many of those, I select the level, I filter out what kind of logs I want to trigger on, and then I can say that, hey, please trigger this webhook when I see at least one of such results over the 15 minutes time window. And trigger this webhook at no more than once per 30 minutes. Once that is set up, what we can do is we can build a custom webhook which would, for example, send a Slack message to the team members saying that, hey, there's a spike of errors or a spike of traces which are slow or something like that. We can, with the custom webhook, you can do pretty much anything. You can send Slack messages, you can integrate with any kind of systems, you can even create some custom webhook which would, for example, restart your server if you would see that it is stuck and you are emitting some specific logs when the server goes down. Or maybe you have some kind of logging which happens on interval to identify that the server is actually alive. And with these settings, you can also say that less than. So it means that if you are not able to find any more logs by these filter options or traces, then trigger this alert. So for example, you are emitting a log message every second or a couple seconds or minutes that the server is alive and healthy. And if the server goes down, then you can say, hey, trigger this alert and inform the team that the server is not providing logs anymore. Another option would be that if you are emitting logs of your visitors when the page is loaded, you are usually emitting logs, and if you are not finding enough logs over your time period, then trigger an alert that something is sketchy happening with that particular server. So alerts, traces, and logs. These are three core things which you need to know that your system is running well. These are the things which every developer needs to have to be able to very effectively investigate what exactly is happening. What something happened a little bit in the past. You have a bunch of filter options in this place. You can select any other time period as needed. For example, if you have a bug report or someone from the users contacted support at some specific date in the past, you can select those dates and see what was happening during that period of time. Same goes for the logs, plenty of options to search. Priority of Otelic is to keep it simple, keep it focused, because other tools just like to provide you a lot of charts and whatnot, and it's overwhelming for the developer to find exactly what they need to find. So that's why Otelic is built in a way to be exactly precisely for the debugging and for understanding your code, so you would be able to fix it in no time. So hopefully this session was useful, and please take a look. If something, contact support for more guidance and info. Thank you.